Hello everyone. We'll be starting in a few minutes. Good evening everyone. I welcome you all to this webinar, OpenCV and Beyond. I, Ali Rashid, a co-committee member of ISTE-VIT, am thrilled to be the speaker for today's session. We have an exciting and informative webinar planned ahead for you. IST, Indian Society for Technical Education, is a non-profit national organization with the mission of equipping engineers with the technical and management skills necessary to address future challenges. We offer a range of programs in departments such as technical, electrical, management, and design, fostering holistic development within our community. We also organize numerous events and hands-on workshops aimed at enhancing the professional capabilities of our members is an annual National Technical Summit hosted by ISTE-VIT. The summit includes a massive hackathon, Technica, and a slew of other events and workshops in a variety of fields such as web development, machine learning, pure electronics, IoT, Web3, app development, and competitive coding. We encourage you to actively participate in our programs and events to enhance your technical and management skills, ensuring a brighter future in the engineering and beyond. Before we dive in, let me briefly outline what we will cover in today's session. We will start with an introduction to computer vision. Then, we will learn about some basic tools used in it. And finally, we will make our own hand tracking project. So, what is computer vision? Computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. Using digital images from cameras and videos and deep learning models, machines can accurately identify and classify objects and then react to what they see. So, a question to you all. Do you know about some applications of computer vision? If yes, feel free to type them in the chat box. Okay. Yeah, object detection. It's one of the applications. Okay, no worries. Some of the applications of computer vision around us include facial recognition. This technology is used in various applications from unlocking smartphones to law enforcement for identifying suspects. Self-driving cars utilize computer vision and sensor technologies to autonomously perceive and navigate the road environment. Medical imaging uses computer vision for medical image analysis, such as the interpretation of X rays, MRIs, and CT scans. It can even help in early disease detection and treatment planning. Augmented reality and virtual reality use computer vision applications to overlay digital content on the real world and create immersive and visual experiences. These are just few of the applications of computer vision. Moving on. Another question. Do you guys know how OpenCV is used in computer vision? Yeah, correct. It is a library. Okay, so let's have a quick introduction to OpenCV and MediaPipe. OpenCV, which stands for Open Source Computer Vision Library, is an open source computer vision and machine learning software library which provides a wide range of tools and functions for various computer vision tasks, such as image and video processing, object detection, recognition, and much more. Some of the features of this software are its open source and free nature, the diverse number of computer vision algorithms that it provides, and cross platform compatibility. Moving on, we have MediaPipe. MediaPipe is another open source framework developed by Google that provides a set of machine learning based solutions for various multimedia and perceptual computing tasks. It is designed to make it easier for developers to build applications that involve tasks such as real time object detection, hand tracking, and pose estimation. Now we'll see as to how images are represented in OpenCV. In OpenCV, images are represented as three-dimensional NumPy arrays. An image consists of rows of pixels where each pixel is represented by an array of values representing its color. By default, OpenCV uses the PGR method of representing colors. In this code, as you can see, we've imported the CV2 library, which is yet another name for the OpenCV library. Then we'll use the imread function to read the image, and we'll store that in the img variable. Then on printing the variable, you can see in the terminal that we're getting a three-dimensional NumPy array, where each array represents the color of that particular pixel. This is a graphical representation of each image, which is made up of the RGB colors. The RGB stands for red, green, and blue. Moving on. How do we load an image in OpenCV? We'll look into that now. Firstly, we'll import the CV2 library. Then we'll use the imread function to read the image. Then we'll be using the imshow function, which visualizes each array of the three-dimensional NumPy array into a pixel and then shows the image in a pop-up. The CV2.wait key, the wait key function is used to check for the input given by the user, and as soon as the user gives an input, as you can see, it says wait key. So whenever the person presses a key, the program goes on to the next line, which is cv2.destroy all windows, and this will close our pop-up window. Moving on. How do we draw shapes in a frame? Well, this is very important, as while working with different models and different detection softwares, we have to create different bounding boxes. A use case for this is, as we've seen, face detection, where we have to bound our faces in boxes, and that we can do by using the different shape functions that OpenCV provides. So here you can see that we've created an variable called image, and in that variable we've used the zeros function in the NumPy library to create a three-dimensional array, where the first parameter 300 and the second parameter 300 are the width and height of our image, and the third parameter tells us about how many channels our image would have. And here we'll have three channels, which are the blue, green, and red channels. Then we'll use the line function to draw a line on our image. The first parameter of our function would be the image on which we want to draw the line. The second would be the point where the line should start. The third parameter will be the endpoint of a line. And these points are given using the x and y coordinates. So basically 50, 50 represents x, 50, the 50th mark on the x-axis, and the 50th mark on the y-axis. The fourth parameter is the color of our the color which we want to give to our line, and the last parameter is for the width of a line. Moving on, now we have the rectangle function. In the rectangle function, the first parameter would be the image. The second and third parameters are the top left point and the bottom right point respectively, and then the last two parameters would be the same as the line function. After that, moving on, we have the circle function. In the circle function, the second parameter would be the center points of a circle. Here we've given them as 100, 100. So the x and y coordinates of a center point for our circle. The third parameter will be the radius of a circle, which we have given as 20. And we're following the BGR code method for representing our colors. So we've passed the third parameter as 255, 0, 0, which represents the blue color. And the final parameter -1 tells us that we want to fill the circle. So this will give us a circle which is filled with the blue color. Now, moving on, we'll see some image processing tasks. So it is best practice to do this, as training models with different parameters of the same image can help them capture more features. So it is always advised to process your images and do different tasks on it so that the models can capture more features and give you a better result. So what two processes we are doing here are, first is the color conversion process, and the second one is the blurring of the image. For the color conversion process, we'll use the CVT color function. Make sure that this CVT color function is available, and then we'll call this function. The first parameter of this function would be the image, and the second would be the color conversion, from which color to which color we're converting our image to. As you can see here, we've given BGR to gray, so our image will be converting from the BGR representation to a gray code. Now we've used the Gaussian blur function. In the Gaussian blur function, we're using the gray image. So we'll give that as the first parameter. Then the second parameter, which is 5 by 5, is the size of a kernel. A kernel is basically a two-dimensional square which moves throughout your image and blurs it out. Here, the size of the image is 5:5 pixels. The more bigger the size, the more the blurriness would be. And then 0, which is the last a parameter of our function, is basically used to describe which type of blurriness we want. If you want a circular blurriness, then we'll put the parameter as 0, or if you want elliptical uh, blurriness, then we'll put it as 1. Then we show the two images using the IMShow function. Now we'll move on to the last part of our theory, which is web connection. Now, the one of the basic tasks is to connect your webcam with your Python. So we'll be seeing how do we do that. We'll import the CV2 library. Then after that, we'll use the video capture function to create a connection between our Python program and the webcam. Then we'll create a variable, uh, Boolean variable, which is true here. Then using that, we'll be making a while loop. We'll make a while loop which is always true, so that whenever we run the program, it also runs. But we need to specify a condition for termination that would bring us out of the loop. So as you can see in the line 10 and 11 is given that condition. Now coming on to the sixth line, what we're doing is we're calling the read function. So what the read function does is it will basically read what input our webcam is getting, essentially our video, and then it will return two values. First is a boolean which tells us if the connection between our webcam and the Python program has been successful or no. If it's successful, then the ret function, ret variable which we have taken, it will be frame variable will store the images which our camera is reading. Then we'll show the image using the IMShow function, where we'll pass the image and the first parameter would be the name of the pop-up. After that, we'll use the cv2.waitKey function, which waits for 1 millisecond for the input of the user, which is by pressing a key, and whichever key the user presses, the waitKey function will return the ASCII code of that key. And then this snippet over here, it says and 0x capital F and capital F. This will convert, this will take the last 8 least digits of our ASCII code, and then it will compare it with the ASCII code of the small q alphabet. And if that is true, then we'll break out of the loop. So basically what it does is if the user presses the Q button, then the pop-up will close and the connection, our video we won't be able to see our video. Then we'll go on to the 13th line of the code, cap.release. What this does is it will remove the connection which we have with our camera, and then we destroy all the windows. Now we're done with all the theory part. We can move on to the coding part of a project. So I'll open VS Code. I'll be sharing the information. Please follow along, and if you have any questions or doubts, please type them in the chat. So the first step which we'll be doing is we'll be creating a virtual environment. So what is a virtual environment? A virtual environment is basically a bucket which stores all of the dependencies that you're installing in your program. So why do we use it? It is always advised to use a virtual environment while making your Python projects, because you'll be installing different libraries and different dependencies and you don't want them to clash with your existing dependencies. So it is always best practice to work on a virtual environment while making new projects. So the code for making a virtual environment is Python M PENV, and then we'll pass on the name of a virtual environment. As you can see, I've already created my virtual environment. So this will show an error. You can go ahead and try it. After that, it will show a folder which will show your virtual environment over here. Then you'll have to activate your virtual environment. How do you do that? The code for that is the name of your virtual environment folder. Then you'll go onto in the scripts folder, and then you'll press right activate, and this activates your virtual environment, which is already there for me. So this is your script folder, and that this is the the activate file. So you just have to call this file, which you can do with this command in your terminal. Okay, so now we move on to create a Python file which will be responsible for our tracking project. So now part of the project would be to set up the webcam connection, which you've seen previously. Firstly, we'll import all the necessary libraries. We're importing the CV2 library or the OpenCV library. We'll import MediaPipe also, and we'll import the PyAuto GUI library. We have imported this, and as you can see, I've already installed all of these libraries in my virtual environment. So you guys will also have to install these. So for installing these libraries, the command is pip install MediaPipe OpenCV Python PyAutoGUI and Pygame. So as you can see, it's downloading all of them, but I have all of these pre-installed on in my virtual environment, so it's showing a requirement already satisfied. So you guys can go ahead and install it on your PCs. Now, guys, make sure to fill in the attendance form, which will be shared on the group on the chat. The form will be shared at the end of the session, so make sure to be there till the end. Now we'll make the variable camera, which will use the video capture function. After that, we'll create our while loop as we've seen before, where the condition will give as true. Then we'll be reading the input from our camera. Now this will return a success, a boolean variable which will be stored in success, and the images which will be stored in frame. So I'll just use this. We'll put a condition that if not success, which says that if the connection is not successful, then we'll break out of this loop. And then we'll show our image show. We'll give the pop-up the name as track, and then pass in the frame. Now we'll pass the condition that when the user presses the Q button, the program stops. So we'll do this. We'll use the wait key function, which waits for 1 millisecond. We'll pass the code snippet for the ASCII code extraction. Then we'll break out of the loop. Then we'll release the camera connection, the webcam connection, and we'll close all the windows. CVT does all windows. Okay, now we'll run this. Okay, so our webcam connection has been successful. Now we'll move on to the visualizing and tracking of our landmarks. So what do I mean by landmarks? I'll show a reference image. So this is the image which is also there on the MediaPipe documentation online. You can check that out also. So basically now what we'll have to do is we'll have to track our hand landmarks, and we'll have to visualize those on the video which we're getting, on the pop-up which we're getting. So for that, we'll be taking the help of the MediaPipe framework or the library which we've installed. So what we'll do is we'll create a variable so that we can access the hand submodule in the MediaPipe library. So we'll call the MediaPipe library, then we'll access the solution submodule. In that we have the hand submodule. So basically the hand submodule consists of all the necessary classes and functions that we can do with our hand, like gesture recognition, tracking of the different landmarks of an hand. That can be, all of those functions are found in the hand submodule. Then we create an object for detecting our hands. So we'll access the variable MP underscore hands. Then it has the MP underscore hands variable will have a class called hands, and then we'll be passing the parameters for this class. The first parameter, which is static image mode, will give as false because our input is not a static image, it's a video. The maximum number of hands we want to detect, we'll give that as 1, and the minimum detection, and these two parameters are important. I'll type them out and then explain them. Yeah, you can use MediaPipe on multiple bodies. I've given the parameter here as the number of hands I want to detect as 1. For example, you're working with some module that provides a body pose estimation. You can give the number of bodies you want to detect as many as you want. So coming on to the parameters which I've passed here, the minimum detection confidence, what this parameter does is it will create a constant, and for the tracking, for the detection of our hand. If that constant is greater than 0.5, then we'll move on to the tracking of our hand. Then if the tracking of our hand, the confidence constant for that is greater than or equal to 0.5, then only the tracking function will be evoked, and we'll be able to, and the model will be able to track my hand. After this, we also need to visualize our landmarks. So we'll create a variable. We'll name it as MP drawing. And what we'll do is we'll access the drawing sum module, which is a sum module in solutions, uh, which is a sum module in solutions, and then we'll be using this because it contains all the different functions that are necessary for visualizing purposes and drawing landmarks, drawing the your different poses that you can do. Now we have created our two variables. We will move on to the processing part. So as you know, we've discussed previously that the normal image channels that are there in OpenCV, they're in the BGR form. But when we want to pass this image to our functions in order to extract the landmarks, we need to create it into RGB form. So we'll create a variable which will store the image. We'll use the now question. We discussed about a variable, or sorry, a function. We discussed about a function which converts colors, right? Which will help us to convert colors. So we'll be using that over here. So if anyone knows, please type it in the chat which function we're using for the color conversion. Right, CVT color, correct, Tejas. We'll be using the CVT color function. We'll pass in the frame and then we'll pass in the color conversion. From which color to which color we want to convert. So we are converting from BGR to RGB. Then what we'll do is we'll pass this image into a function which is in the hands object, and I'll tell you the function. The function we'll call after the success condition. Here we'll store the result in a results variable, and we've created the hands object, and in the hands object there's a function called process which will process the image which it's getting, and this will be responsible for tracking our hand. And what this does is it returns a list which contains the landmarks of our hands as objects, and each landmark will have one x, one y, and one z coordinates as its attributes. So each landmark, as you can see here, each landmark here out of these 20 landmarks will be represented as an object, and each object will have its x, y, z coordinates as its attributes. So now what we have to do is, in order to visualize this, we'll loop through each hand landmark and we'll pass that landmark in the MP drawing variables function, which is named as draw landmarks. So I'll code it out and then explain it to you. Firstly, we'll check if it is returning a list or no, as if it's detecting our hands or no. That is done using this. We'll be accessing the list. Then we'll be looping through each hand landmark. Now we'll be drawing or visualizing it using the draw landmarks function. Draw landmarks. We'll pass in the frame on which we want to draw visualize the landmarks, draw the landmarks, and then we'll pass in the landmarks object, and then we'll pass in the connections. So this last parameter Oh, this is empty hands. So this last parameter, what it does is, it is an enumeration which consists of all the landmarks and their numbers. So basically the landmark 0, which is named as rest. So this enumeration or constant is already there in this function, which specifies that the 0th index contains the rest object, the landmark rests object. Now we'll run this code. Okay, so as you can see, our tracking and visualizing is working. Now we'll move on to extracting the y coordinates of our middle finger and its base. So in this for loop, as you can see, we are accessing the list which contains all our landmarks. So now we want to extract each object and then access its y attribute or its y coordinate. So that we can do by creating different variables for each landmark. So we'll create a landmark for our middle fingertip, and then we have the hand landmarks object, and in that we need the list to access each landmark, and that list is inside this landmark list which we're accessing using the dot operator, hand landmark, and then we pass in the enumeration or the constant which tells us that we need the object which is named as wrist or the middle fingertip. Land mark and index finger tip. That's done. Similarly, now we'll take the middle finger, pay and landmarks dot landmark. We'll pass the enumeration for our middle finger space. That, as you can see here, is represented as the 9th landmark, and the enumeration of the constant name for it is middle finger underscore middle underscore finger underscore MCP. Middle underscore finger underscore MCP. Right? Here the objects. Now what we want to do is we'll also take out the object for our wrist later on in the project. So let's take it out over here only. We pass the enumeration for our wrist. Now we're done with this. So we've extracted the objects. Now we want to display the y coordinates of our object on the pop-up window that we'll get of our webcam. So we'll use the function which is provided by CV2 called called put text. So we'll write put text, and that the first parameter would be the frame which we want to display our string or display our coordinates on. Then we'll pass in a string, the string which we want to display. So we'll be using a formatted string. We'll write middle tip, and we'll pass the middle fingertip object, and we need the y coordinate of the object, so we'll be accessing the y attribute. After this, the third parameter, okay, right, what we'll do is we'll pass as the coordinates where we want to display our text. Then the font. CV2 library provides a lot of fonts which you can choose from. So we'll just take the Hershey plain font. And then we'll pass in the font size, which we'll passing as 1, and then the color for our text, and then at the end we'll provide the thickness we need for our text. So with that done, we'll try this out, run this. Okay, so it gives us an error which says that hand landmarks dot landmarks. Okay, in line 31, we've we have to rename this as just one landmark. We're accessing the landmark object array twice, so we need to access it once. Run this. So as you can see on the top left, it's showing us the y coordinates, but it's not relative to our frame. So we'll just tweak the code a bit. What we'll do is we'll multiply this with the height of our frame. So we have the frame. In the frame, we access the shape of the frame using the frame shape attribute, and in that we'll need the zeroth attribute, which is the height of our frame. And what we'll do is we'll round this using the round function. We'll round this to 2 decimal places. Okay, and for more visibility, we'll change the color. We'll keep the color as blue here, as we're following the BGR method of representation. So let's do this. If you guys have any doubts, please feel free to type them in the chat. So yeah, as you can see, it is visible. Okay, so now what we'll do is we'll do the same thing, and for our middle finger base and the wrist landmark, we'll rename this as middle base, and then we'll rename the object which we are accessing. We'll do this, we'll rename this as middle base, that way, and then we'll change the y coordinates here. This will rename as wrist. We'll access the wrist object, and then we'll change the y coordinate of this. Now we'll run this. Let's see. Okay, so two of the fonts are overlapping, so the y-axis are same, so we'll change them. Yeah, so we'll change this to 120. Okay, now what we'll do is we'll highlight, we'll be using a function which we have seen previously, so we'll be using that to highlight our middle finger base and tip. So we'll first access the x and y coordinates of it. We'll do that by creating a variable for each of the x and y coordinates. So we'll do this middle finger tip x is equal to middle finger tip. We'll access the x coordinates, we'll multiply them, the frame shape, I'll multiply it by 1. So what is the frame rate which we are supposed to be getting? The frame rate, it depends on your PC over here. We have not specified the frame rate. It depends uh, on your PC. After this, we have to take the y coordinates. Middle finger dot underscore tip. We need the y coordinate of that, and we'll multiply it as. Now we need these values which we are getting as float values, as you've seen by the display. We'll typecast these into integer values. So a question out there, we'll be using a shape to visualize our landmarks. So what function or that we previously saw in theory, which function can we use to draw those landmarks or to signify those landmarks? Hmm. Okay. So the function which we will be using is the circle function. So for that, we'll need the x and y coordinates, which we have taken out for the middle finger tip. Now we'll take the x and y coordinates for the base of the finger. We can copy paste this here. And name this as base. And this is the y coordinates of our base. We multiply it with the frame shape so that we're getting the coordinates relative to our frame. Need the height, so we'll put the index as 0. So we have those. What we'll do is we'll use the CV2 circle function. Pass in the frame on which we want the circle to be. We'll pass in the x and y coordinates. Then we'll pass in the radius of a circle as we've seen previously. Then the color which we want it to be, I'll put it as green. So for green we need to put 0, 255, 0. Then we'll fill the circle. We'll do the same thing for the base of the finger. Okay, that's done, and I'll color this as, let's say, blue. Now let's run this. Okay, so we've taken the index finger, so it's taking the index finger's x and y coordinates. So no worries, that works. We've taken those here, and then here we are taking the middle fingertip. We'll just rename this so that we're getting the middle fingers object, middle underscore finger underscore tip. Let's see if there are any other changes that we'll have to make. Okay, yeah, that's it. So the only change we had to make was we had to rename this as middle fingertip. Run this. Okay, so as you can see, the middle fingertip and the base are being visualized, and we're getting the x and y coordinates of it. Right now we haven't visualized the landmark for our wrist. We'll do that later on in the project. Now moving on, in order to test our project, what we'll do is we'll make a simple 2D game using a library called Pygame. So we'll create a file, we'll name it as game.py, and then we'll import the Pygame library. The Pygame library is just a simple library which we can use to create 2D games and implement 2D game logic. So we've imported that. Now we'll initialize all of its submodules. After this, what we'll do is we'll just initialize some constants. So we'll take the width of the screen of our game as 400 and the height as 600. Then we'll move on and take simple dimensions contents of our game. So the game which we're trying to build over here is a simple ball and basket game where a ball will be falling from the top and you have to catch it using a basket, where the ball here will be a circle and the basket will be a square of your given dimensions. So we'll take the ball radius as 20, and then we'll give the basket size as 50. Okay, we'll also initialize some constant colors. So 255 to 55 to 55, which represents the white color. And then to represent the red color, we'll use 255, 0, 0. I hope everyone is understanding and are able to follow. If you have any doubts or questions, feel free to type them in the chat box. Right, so we've taken the white and the red colors. What we'll do is we'll create a screen for our game. So that we can do by using a function called set mode inside the display submodule of Pygame. So we got that function, the x and y coordinates of that function. So the first parameter which we're given are the width and height of our screen. Now what we'll do is we'll create a caption for our game. That we'll do using the set caption function. Then we'll pass on the name of our caption. After this, in order to set the FPS of our 2D game, we'll create a variable called clock and we'll access the clock function. Then, as we've done previously, in order to create a infinite loop until a particular condition is given, we made a while loop which was always true. So we'll do the same to make the main loop for our game. So we'll make a while loop and we'll put it as true. Condition will be true, and then what happens is that in Pygame there's another submodule called event which keeps track of the interactions of the user with the mouse and the keyboard. So we'll be accessing that submodule, and that each event or each interaction we'll be accessing using a for loop. So pygame dot event dot get, this will return all of the interactions that the person or the user is doing with the hardware. Okay, now if the event type is equal to pygame.quit, I'll code it and then explain it. Then Pygame.quit. So what happens is that we check if the event type is the same as this Pygame.quit. So basically this is another constant which tells us that whenever we click the Q button or the Q key, then this if this event type matches with the clicking of our Q key, the game will quit, and we'll do that using the quit function in Pygame. After that, we'll move on to filling the screen which we are getting. So we'll do that using the screen fill, and the color will be white, as we can see that over here we've already created that constant color using the RGB color representation form. Then we'll constantly update our screen. So we'll do pygame dot display, and in that we'll access the update function which will update our screen. Depending on the FPS you're putting, it will update it according to that. Then we'll state the of our game. So we'll state it as 60 over here. Then we'll run this. Okay, it says that does not have rate, so it's set mode. This underscore, we don't need it, it will be set mode. We'll run this. It says has no attribute tick. Okay, so we in this we need the time module or the tick module. The tick is a function, so we take the tick, remove the tick submodule and put the time submodule. So as you can see, we're getting a sample template of a game on which we'll be building the components. What we'll do is we'll be displaying the ball and basket. So before doing that, we should understand as to how the logic of the coordinate system is in Pygame. So let's say this is our frame. I'll take a rectangle. This was our frame, which was of dimensions 400 into 600, right? So in Pygame, the screen which we are getting, the initial x and y coordinates or the origin of the screen will be on the top left corner. So this will be the 0, 0 point. Then what we'll do is we have to see that it's the coordinate system followed by Pygame is not the same as the normal coordinate system. This axis or the x-axis is treated as the positive x-axis only, same as the normal Cartesian coordinate system. But this axis, unlike the normal Cartesian system, is not negative. This is treated as the positive y-axis. So this coordinate 400 comma 0, and this coordinate will become 400 comma 600. Sorry, this will become 0 and 600 as we're moving in the y direction only, right? And then this will come to be 400 comma 600. So the point we have to keep in mind is that as we move downwards, the y coordinates of the particular object we are tracking is increasing. It's not going in the negative values, it's increasing. Now what we have to do is we have to initialize the coordinates of our ball and basket. So let's say we need the coordinates of a ball to be at the center of the screen. So we'll take its x coordinates as half of the width and its y coordinate as 0. So we'll code it out. Here we'll write the ball underscore x equal to width divided by 2. Then we'll take the y coordinate of a ball as ball underscore y equal to 0. Next, we'll take the basket x and y coordinates. Basket size, and divide it by 2. I'll code it out and then explain why we're subtracting the size of the basket from the width. Then we take the basket underscore y equal to height minus basket size. When we're done with the initializing the x and y coordinates. So why we have done this is we've taken the x coordinate of our basket and the y coordinate of our basket, and then subtracted the basket size because we don't want our basket to go out of the frame. So let's say this is our basket, this is the center of our basket. We don't want this basket to go out of the frame, so we're subtracting the size of the basket from the height and the width of the frame. So we want the basket to be like this. Half of it should be visible. So that is why we're subtracting the x and y coordinates of our basket size. Then after this, we'll draw the ball and basket, and we'll be doing that using the draw sum module. And in that we have a function again named as circle. See, then we'll pass the screen on which we want to draw, then the color, we'll pass it as red, then we'll pass on the x and y coordinates, underscore x, ball underscore y, then the ball radius as the last parameter. After this, what we'll do is we'll draw the basket. Pygame dot draw the same submodule. We'll use the rect function to draw the basket. Pass in the screen, color, and the x, y coordinates of a basket. Then finally, we'll pass the basket size of the dimension of a basket, which is the length, the height and width of a basket are the same. So we'll pass this same constants. Now we'll run this. We'll firstly put the Pygame display function below this so that it will update our screen as soon as the basket and ball are displayed. Okay, so as you can see that the half of the ball is only visible because we need a falling effect. So I've not subtracted the dimensions of the ball from its y-axis, and a square, which is our basket, is visible over here. Now what we want to do is we want to make the ball fall. So let's say the initial position of the ball is this. Now the ball has to fall downwards, right? So we can see that the y coordinates of the ball, which ball will change as it falls, right? So what we'll do is we'll implement that logic by saying that if the main loop is running, then the y coordinate of the ball should increase at some constant rate. So we'll implement that here. What we'll do first is we'll take a Boolean function which tells us if the ball is falling or no. So we'll take it here. We'll create a variable called ball underscore falling, and we'll name it as, we'll give it as a value true. Then what we'll do is go into the main loop of function. In that we'll give the condition that if the ball is falling, then we'll change the y coordinates of our ball by 5. Now what we'll do is we can We need to cross check this and we'll run this. Okay, so the ball, we'll put the clock tick in the for loop, in the while loop. Now we'll run this. So you can see our ball is falling. Now what we have to do is we have to work on the condition that if our ball has gone out of frame and you want to bring it back onto the frame. So what we'll do is we'll put that condition at the end of our script. What we'll do is we'll put the condition that if the ball y is greater than the height, then ball falling will be false, and ball the ball's x coordinate will reinitialize to the starting coordinates which were there, and the y coordinates was 0. And then we'll again say that the ball falling condition will be true. Okay, now this we have done. We've created the variable that the ball is falling, and then this condition which we've given here, it should be indented in the true loop. Put this here while true. This is true, then we have filled the screen. Okay, as you can see, all of the condition for the ball height has also been given. Now we'll run this. So the ball is falling, and whenever it is out of the frame, it comes back to the top of the frame. Now what we have to do is we have to work on the movement of our basket. So what we'll do is we'll go on to the top and we'll be using another function which is provided by Pygame in order to get the x and y coordinates of our mouse, because we'll be controlling the basket with the x and y by the cursor of our mouse. So we'll be using that. What we'll do is, in order to keep the condition, we'll reindent this. We'll take all of these conditions back to keep them inside the true loop, the while loop, not inside the event loop. So we'll just reindent them. Now we'll run this just to cross check that it's working. Our ball has disappeared because we haven't given the draw function inside the loop, right? So what we'll do is, just a minute. We'll put this as true, and then we fill the screen. Now we'll run this. Oh, our ball is still. So we'll look into this. Okay, so we've taken the update function inside. So we'll take this outside, the clock function also. This shows up. So what happened over here is that when we give our update function inside this event loop, it basically checks if there is an event, and if there's an event or an interaction with the hardware, as in the keyboard or the mouse, then only it will update our display, and then only our ball will be visible. I hope everyone was able to follow and there are no doubts. If there are any, please feel free to put them in the chat box. Right. So with this done, now we'll move on to the movement of our basket. I'll, as I mentioned, we'll be using a function which is provided by Pygame to get the x and y coordinates of a cursor, and then we'll be taking those after filling the screen with the white color. We'll take two variables, mouse underscore x and mouse underscore y, and the function which we'll be using is mouse inside the mouse submodule. The function is get underscore pos, and this will return the x and y coordinates of our mouse. Now what we have to do is we have to reinitialize the x and y coordinates of a basket to the x and y coordinates of our cursor. So basket underscore x will become mouse x minus basket size, and we'll divide this by 2. Similarly, we'll initialize the y coordinates also, mouse underscore y minus basket size. Where did I put? Now we're done with this, and this should give the x and y coordinates to the x and y coordinates of a mouse. So now you can see as I'm moving my cursor, in the same time the basket is also moving. Now we move on to the collision part. So what do I mean by collision? So let's say that the basket is here and the ball is here, and the ball moves and the basket is over the ball, and there's a condition where these two are overlapping. And then at this condition, if the person or the user is clicking the right click, then we want the ball to disappear, as in we have caught the ball. That's the gist of our game. So when we're catching the ball, this occurrence of overlapping which happens, this is known as collision. So in order to deal with this collision, we have to treat these individual components as invisible boxes. So whenever these invisible boxes or rectangles, collide, then there should be a collision, and then the ball should disappear. It should go out of the frame and only the should be visible, while the ball reinitializes its position and it starts falling from the top. So in order to work on the collision, firstly we'll have to create the invisible boxes, and then after those invisible boxes have been made, we have to check if they're overlapping, and then and both of these conditions will only be happening when we're right clicking our mouse. So we'll be going into the event loop which we had taken previously, and in that event loop what we'll be doing is we'll be checking if the event type is the same as our right click of the mouse. So we'll check if event type is equal to pygame dot type pygame dot mouse button down. So this is done. We've checked if we're pressing the right click. Then we'll create the invisible boxes for our ball and basket respectively. First we'll create for the ball. We can create the invisible boxes using the separate function which is called rect. This is not the same as the small r rect function which is made to use a rectangle. This is basically made to this is the function which we invoke in order to make those invisible colliding boxes. So we'll pass in the first parameter, which is the x coordinate of our invisible box, and then the y coordinate for it. We're just subtracting the radiuses so that the box size doesn't become too big. Then we'll pass in the size of the box, as in the length and the breadth, or the height and the width. We'll pass it as double the radius of a ball. Okay, ball underscore radius. After this, we'll create the basket rect. Dot, we'll pass in the x and y coordinates again here. Basket underscore x, comma basket underscore y. And then we'll pass in the sizes of a basket. With this done, we've created our invisible boxes. Now we want to check if they're overlapping or not. So we'll put the condition. We've made our invisible box for the ball. So we'll check if the invisible box for the ball is colliding with the box for the basket using the collide red function. We'll pass in the basket rect here, and if this is happening, then what we'll do is we'll pass in the condition that ball falling should be false, and the width of our screen should be the half of the width of our screen should be the x coordinates of a ball divided by 2. The ball y should become as 0. Ball falling will become 2. Now let's test this. We'll run the program. Okay, so now you can see that the ball, whenever the ball is colliding with the square or a basket, it goes back to its initial position. Now we'll add a score to make it a little competitive. We'll put the score variable as 0 here, and then we'll say that whenever we're catching the ball, whenever the collision is occurring, we'll increase the score by 1. And in order to display it, we need a font. So we'll be accessing the font using the submodule in Pygame. So that's the Pygame font submodule. We'll take a variable font, pygame.font. We access the font class. We'll give the first parameter as null because we'll be taking the we'll need the basic font, and then we'll be passing the size of a font. After this, at the end, before the updation of our screen, what we'll do is where we had given the code for the drawing of our circle and rectangle, we'll pass in the same for our score. So we'll create the variable which we want to display, score underscore text equal to font dot render. We'll use a formatted string score, then we'll pass in our score variable, then pass true. So, and then we'll press the color of our text. So this second parameter true is basically it tells the submodule to execute a function to smoothen the edges of our font so that it doesn't look blurry. And we'll use the screen grid function, and then we'll put the score text or the string which you want to display, as we have taken that in this variable. Then we'll pass the x and y coordinates. Now we'll run this. So as you can see, we have a game over here. Right now the x and y coordinates for our ball are static, right? It's coming from the middle always, which is very rep- so we'll just change the x and y coordinates. We'll randomize them. We'll import the random library, and then what we'll do is in this while loop, we'll take the x coordinate as random. So we'll access the random library. So does anyone know which function we'll be using to get the random value? We'll need a random integer, so which function would we be using for that? If you know, then please type it down in the chat. Okay, so the function which we'll be using is the random function. The random function, it will take into its parameters the starting and the ending integer which you want. So we'll specify the starting and ending integers to be 20 and 6. Let's say the width of our screen over here is 400, so we'll put it as 380. Then put the x and y coordinates of the ball. We'll reinitialize them. Let the y1 be 0 only. Let it fall from the top, and we'll take the x coordinates as the random x which we have. Now let's run this. The ball is falling from different x coordinates. Now with that done, we have a 2D game to test our tracking project. Now we'll go back to the tracking file. I'll show you the logic which we have to implement in order to play our game with just using our hands. So I'll run this file. Right, Anantha, it's the random.random function it was we used. Right, so we're able to track our middle fingertip and its space. Now we need to implement the logic with which we can play our game. So what we'll be doing is we'll be comparing the y coordinates of both of these circles. Why is that? So in order to automate the clicking part of our mouse, we want to do the same thing while we are closing our fist. So when we close our fist, you can see that the y coordinate of this green circle, it's increasing, and it's more than the blue circle's y coordinate. So we can use that logic to implement the closing of our hands. So whenever the y coordinate of the tip is more than the y coordinate of the base, we can say that the hand is closed. Our hand is closed, right? So we'll do that. And in order to move the cursor with our hand, we can just give the coordinates of any of a landmark to the coordinates of the cursor, and then it will move automatically. And in order to automate these functions, these logic, we'll be using the PyAuto GUI library, which we have over here. So I hope that everyone was able to follow till the game. And now I'll move on to the automation part, where you can play your game by just using your hands. So we've taken the middle finger base, x and y coordinates, its finger, x and y coordinates. Now what we'll do is we'll also take the x and y coordinates of our wrist. So we'll put them as wrist underscore x is equal to wrist dot x, and we'll multiply it by the width of our frame, and wrist underscore y, wrist dot y, we'll access the y coordinate and we'll multiply it with the height of our frame. That done. Now, as I said, we'll be using the PyAuto GUI library in order to automate us. So the PyAuto GUI library provides various functions which we can use to replicate the user interactions, and we can automate them. So right now we have the x and y coordinates of our wrist. What we'll do is we'll use a function called move to function in the PyAuto GUI library. We'll access it. Well, we'll pass in the x and y coordinates of our wrist. We've passed in the x and y coordinates of our wrist. After this, what we'll be doing is we'll be running this and checking out if our cursor is moving as our hand moves. So as you can see, the cursor is moving as I move my hands. In order to make it more accessible, what I'll do is I'll multiply these coordinates by 2, and in order to not get confused between my left and right hand, what I can do is I can just flip my image. So whatever image which we were getting, you can just flip it using a function which CV2 provides. That function is flip function. So as soon as we're reading the frame, what you can do over here is we'll flip the frame. Frame is equal to CV2 dot flip, and then we'll pass the frame and then 1. So we'll run this. Okay, just a minute. I'll run this. Right, so this is my right hand, and then you can move the cursor with my hand, as you can see. Now we need to automate the part where we're closing our fist, and we can then on doing that we can just perform the right click operation on our mouse. So what we'll do is we'll type out the code. If the middle finger tip y coordinate, which is the y attribute, is greater than the middle finger tip x coordinate, what we'll do is we'll perform a function which is provided by the PyAuto GUI library, which is right click. As simple as that. We'll do pyauto.gui dot right click. So what I'll do is I'll run my game in this terminal, python game.py, which is running perfectly, and then I'll create another terminal where I'll run my game, the track file for tracking our hand. Okay, sorry, we'll run it again. Okay, so we have it here. So as you can see, I can control the game with my hand, and then I'll try to catch the ball, and then let's see if it's increasing our score or no. Okay, yeah, so it basically caught, where we caught the ball and it increased our score. In order to make it a little bit easy for me, I'll just reinitialize the x and y coordinates. So what we can do is we'll put this as width divided by 2, which was before this, and then the same thing we'll do at the end here, width divided by 2, right? Run this. Okay, the ball is starting from the top only. Now we'll run this again. Python game.py, then our tracking file python track.py. Okay, I'll try to catch it. Okay, so I think there's a variable which is causing this. Okay, so what we've done here is we've given the tip condition at the same time. We've given the y and x conditions. We need to give the y coordinates of the base. So we'll tweak that change here. We'll do middle finger base dot y, and then we'll close this by pressing the Q button, which condition we've given over here. And now this condition which we have given for the right click of our mouse, which we are automating, this should work perfectly. I'll run this while a game is running here. It's running. Okay, so yeah, I got it again. I'll try. So I'm able to catch it. That's it there. We have created our automated catch the ball game. And with that, we have completed our project. Hope everyone was able to follow along. And if you have any doubts, feel free to type them in the chat. The attendance form and the feedback form will be shared on the chat, the links for them. Make sure to fill those. Yeah, sure. So I'll run the code again and I'll explain it to you. But I'll just remove this function so that it's not automated again. I'll comment it out. So as you can see here, this is the tip of our middle finger. This is the base. Now we want to automate the action of the closing of our hands to the right click of our mouse, right? So as you can see over here on the top left corner, the y coordinate of our green circle, the tip of our hand, will increase as we close our hands, right? It's greater than the y coordinates of a blue circle. So we'll give this condition for the program to know that whenever this happens, we want to perform the right click operation. And whenever the right click operation performs, we can we made the game, and whenever the right click operation is happening, then we are catching the ball. Why have we taken this only these two coordinates is that we can close our finger by just if we close this forefinger, then it would not be counted as our fist being closed. Using the middle finger, then it will mean that the fist is closed, and then this will automate the action. That is why we've taken the middle finger base and tip. You are able to understand, Anand. Okay, so the links for the Google, the links for the attendance form and the feedback form are going to be posted on the chat. Please make sure you fill it. Okay, great. Now, with that, this is me. I'm Ali Rashid. I'm a core committee member of IST VIT, and these are my socials. Feel free to message me if you want to talk about projects and machine learning, or if you have any doubts regarding this domain. I would love to respond to them. And to be posted about other activities hosted by IST, you can follow us on the following social media pages. We regularly conduct these events, and we would encourage you to take part in these to work on your management and technical skills and to be a better engineer. And that's it from my side. Thank you for your time. Bye bye.